napuno yata, automatic na yun. Start na ako. Kaya ikaw nga magano sa akin. Pag napuno yan, automatic. Okay, good day everyone. Welcome to Nice Powerhouse Team Review and Training Center. Today, we will discuss the direct current circuits part 5 about the Kirchhoff's laws. So this is just the first part of Kirchhoff's laws. By the way, here's my name. My name is Engineer Reggie and Marinay. Just call me Kuya Reg, no? To our Filipino friends, to our fellow men. Okay, good day, good morning, good afternoon, good evening. If there are non-Filipino audience, no, listening to us or viewing to our YouTube live stream. Okay, so let us start our discussion about the Kirchhoff's laws. Okay, Kirchhoff's law. This was developed by the German physicist named Gustav Robert Kirchhoff. Okay. How do we pronounce this? In the Philippines, we pronounce this as Kirchhoff's law. Kirchhoff's law. But I watched some lecture video in YouTube. They call this, some foreigner, they are American, British, and they call this as Kirchhoff's law. Kirchhoff's law. Maybe we can follow them, okay, about regarding the pronunciation. It's the Kirchhoff's law. So named after the Gustav Robert Kirchhoff from 1824 to 1887. Those are the years of also of Nikola Tesla and Thomas Edison, I remember. Okay, so we have the first law of Kirchhoff's. We have the Kirchhoff's current law. That is what we call the KCL, Kirchhoff's current law. It states that any electrical network, the algebraic sum of the currents meeting at a junction is 0. So in equation form, so we have this equation, the summation all or sign convention. The summation of the current is equal to 0. So here, Kirchhoff's current law. A current entering at a junction must be preceded by a positive sign. A current leaving a junction or a node must be preceded by a negative sign. There is a point in the network wherein the current will separate into 2, into 3, or it depends on how many branches you will have. So, for example, we have this current, we have current I1, and then current I2, and current I3 and I4 is leaving the junction. So, we'll be having this equation. At point O, we have this equation, current entering, that is a positive, I2, current entering also, that is positive. I3 is leaving at point O, so that is negative. I4 is leaving, that is also a negative in sign. That is a simple Kirchhoff current law. Okay. So let's have now the Kirchhoff's mesh law. Okay. The Kirchhoff's mesh law, it states that the algebraic sum of all the voltage drops of resistances across its conductors in any closed path in a network, plus the algebraic sum of the EMFs connected in that path is equal to 0. So the summation of the voltage drop. The voltage drop, this is a simple Ohm's law formula. And then, you have to add this to the summation of the EMFs. That is equal to 0. Okay. There is a sign convention for Kirchhoff's voltage law. A potential rise must be preceded by a positive sign. So we have a positive sign for the potential rise. Then we have a must be preceded by a negative drop. Okay. Let's go over with potential rises. Potential rises or potential rise, the potential rises when going to a voltage source from negative to positive terminals. Okay, so that is negative to positive terminals. There is a potential rise. Let's take a look over at our figure. Our potential rise. Potential rises from B to A. From B going to A. So meaning, if the current, well, anyway, we are following the conventional flow of current, which is internally that is negative to positive. No? Just like we discussed before in our electrical principles. No? For those who were not yet viewed our or watched our lecture about electrical principles, you may take a look at our at my YouTube channel. Okay, so we have here inside the battery, the tracing of the current is from negative to positive. That is what we call internally. But externally, it will flow on a counterclockwise direction. Okay? Because inside the battery, that is negative to positive. Internally, that is negative to positive. But externally, that is positive to negative. Externally. Internally, that is negative to positive. That is the basis. I have a little technique to it, to this. If the current leaves the positive terminal of the source, it leaves, no? So, doon siya lumabas. Okay? So, pag lumabas siya sa positive terminal, it is a potential rise. When it leaves on the positive terminal, we have what we call the potential rise. Meaning, if that is positive, there is a rise. Okay? Potential rise. It lives on the positive terminal. Let's say this marker is the current flow, so it lives on the positive terminal, so therefore it is positive. That is a potential rise. Going to a resistor in the opposite direction. Take a look here. Going to a resistor in the opposite direction as the flow of current. So the flow of current is this. Okay? Going through a resistor in the opposite direction. So, let's say this is our current flowing to our resistor. Then there is an assumed direction of the circuit tracing. A circuit tracing is the assumed circulating current in a network. So, let's say this is the assumed circulating current in the network. Okay? It says here, going through a resistor in the opposite direction, if the circuit tracing, see there is a circuit tracing, there is uh, an assumed circulating current to a certain loop. If the circuit tracing is going to the left and your assumed current is going to the right, they are in opposite direction, so therefore it is a potential rise. It is a potential rise. Okay. What about the potential drop? going through voltage source from positive to negative terminals. Okay? So potential drop going through a voltage source from positive to negative terminals. If the direction of the current is from positive to negative, just like this one, there is a potential drop. Or when it leaves on the negative terminal of the battery, you see, let's say this is the arrow of the current, it leaves, doon siya lumabas sa negative ng baterya mo. So meaning, it is a potential drop. What about here? Going through a resistor in the same direction as the flow of current. So there is a circuit tracing here, the assumed circulating current, that is assumed to be clockwise, that is going to the right, and this is also going to the right. They have the same direction, so therefore it is a potential drop. If it is positive, that is potential rise. If it is negative, that is a potential drop. Okay? Okay, I will give you a summary. Let us have a summary of the Kirchhoff's law. Okay, let's have now the summary of the Kirchhoff's law. Kirchhoff's current law. What is the summary? Okay, so let's say we have here a node, then there are two branches here. We have here current I1, we have here current I2, current I3. Okay, it says summation of the current is equal to 0. The current entering is positive, so that is our positive I sub 1. The current leaving is negative, so that is minus I sub 2 minus I sub 3. That is equal to 0. Or, shall we say, I1 is equal to I2 plus I3. We may summarize this as the current entering is equal to the current leaving, or the current leaving at a particular junction. Okay? That is the summary of the Kirchhoff current law. What about the KVL, the Kirchhoff's voltage law? Okay. So for Kirchhoff's voltage law, let us have first our source of EMF. Our source of EMF. Let's say we have here a battery. So the longer one is the positive, the shorter one is the negative. Let's say we have here our E. Okay, this is our E. This is positive, this is negative. Okay. This is what we call our circuit tracing. See? Okay. Again, this is what we call our circuit tracing. Circuit tracing is the assumed circulating current loop. That is just for guide with an equation particular. This is what we call the circuit tracing. Tracing lives. So it is a positive E. I never assume a clock counter. I always assume to be a clockwise there. A clockwise, right? Clockwise. So that we will confuse along the way when you are calculation or analysis in your network. So if the thing leaves the negative terminal of the battery, so this is a negative E. That is negative. Like, ha? Naririnig niyo ba ako dyan sa inyo?
Sir, paputol-putol po, sir.
Do you hear me in your place? No. Putol. May mic.
Medyo mahina, sir.
Sir, may disturbance yata.
Kailangan naririnig ko yung boses ko sa speaker. Hello, hello. Do you hear me? Naririnig po ba ako? Leo, naririnig mo na ako? Okay. Pag ito, wala? Ayan, naririnig na. Okay, rinig po ba, Leo? Rinig na? Maka-aware pa, paki-respond lang po tayo. Please cooperate po. Naririnig nyo ba ako? Kung hindi, mag-raise hand kayo pag hindi po maayos. Kasi online po tayo.
Now, clear now, sir. Clear.
Okay, sige.
Clear now, sir.
Tuloy lang natin.
Okay na, sir.
Okay. So, again, for the KVL, if the circuit tracing leads on the positive terminal, that is positive E. If it leads on the negative terminal, that is negative E. Can you follow, everyone? Please show to our audience that we have
Yes, sir. Yes, sir.
class here. Nakasunod ba? Aris, naririnig mo ba ako ng
Okay po, sir. Okay.
Sige, adjustment. Sa aking kapwa Pilipino, reply naman kayo. No? Tulungan nyo ako dyan sa inyong ano. Mahirap itong ginagawa natin. Live to eh. Kami nakikinig na Amerikano, mabwisit sa atin. Okay. Sige, so, at possible. Huwag nyo sabihing imposible to dahil ilalagay sa YouTube to. Nakita ko na po, may mga iba-ibang lahi tumitingin sa aking video. No? And even nagko-comment po sila. Okay, let's continue this. Let us apply what we learned in the principle. Okay, this is example numbers 1 to 4. I will redraw the circuit. Drawing natin, ha? So, tapatan mo muna doon para makopya din nila. Okay, ako kokopyahin ko yan sa whiteboard. Okay. So let us list down all the given. We have 200 volts. Here, we have 50 volts here. Okay, we have 100 volts. We have 10 ohms. We have 12 ohms. We have 5 ohms. We have 5 here, and we have 8 here. Okay, let's double check. 250, we have 100, we have 5, 10, 12, then 5, then 8. Okay. So there is already an assumed direction of the current in our circuit. we have our I sub 1 going to the right, I sub 1, then I sub 3, that's going to the right also. Then we have I sub 2. Okay. So let us put our nodes. Okay, or this point. Okay, so this is point A, point B, point C, point D, point E, and point F. Okay? Leon, naririnig mo ako, hindi ba ako napuputol sa'yo? Okay lang? Okay lang. Okay, sige. So, this is the given. Okay? Kita na natin dito. Nakopya ko na siya. So, ito yung given natin, mga kawerpa. This is given in our problem. We have the, kasama na, there is already the assumed direction of the current. This is the assumed direction. Okay? There will be no problem in assuming the direction of the current. No? Whatever direction you want it. No? But me, I usually do is also if you are to trace the direction of the current, I usually do again in a in a clockwise direction. Okay? So take a look here. Actually, in this problem, we are asked to find all the currents. Okay, this is on problem 1, 2, 3. We are asked to find here our I1, I2, I3. For number 4, we are asked to find here, I think, voltage from A to D. That is the question. We'll be solving this problem. Okay. First, by current law. Okay. Ano, putol-putol ba? Pag yung mic ka gamit. Hello, hello. Yung mic hindi napuputol. Mas okay ba yung may mic, Leo?
Sir, okay lang. Okay lang.
Sige. Mag-mic na lang ako, Aris.
More clear on mic, sir, but it takes difficult on your side, maybe.
No problem with me. That's no problem with me. Okay. So, let us continue. By Kirchhoff current law, take a look here. Take a look. Let's have the Kirchhoff current law at node B. Parang putol yung sound. Hindi naman ganyan dati. Putol yung. Okay naman. Okay, at node B, lagyan mo ko ng monitor, hindi ko marinig. Lagyan. Okay, hello, hello. Hello, hello. Okay na ba? Hello, sound check. Rinig na, rinig. Okay.
Yes, sir. Yes, sir.
Yes, sir.
Hello, hello. Okay, so let's continue. Okay, this node B. Okay, by Kirchhoff current law at node B, so this is our node B. Okay. The current
entering is I sub 1. So we have here I sub 1. We have I sub 1. And the current living is I2 and I3. I sub 1, then we have minus I2 minus I3 is equal to 0. Okay, so we have this I1 minus I2 minus I3. Okay, so the current entering is positive, current leaving is negative. I1 minus I2 minus I3. So let us say this is our equation number 1. Okay, let's have now our equation number 2 and 3. There should be 3 equations because there are 3 unknowns. Okay, so let's go over here. So we have by Kirchhoff's voltage law at loop. So loop. Let's have now the first loop. I will put here the tracing here. Okay. So let's call this as A B E F A. A B A B E F A. So we have to close the loop. Or simply KVL at loop 1. Let's say. So this is our loop 1. This is our loop 1. Okay. So let us treat this as our loop number 2. Okay. So let's have first our loop number 1. This is our circuit tracing. The circuit tracing, the assumed circulating current, it lives on the positive terminal of the 200 volt. So therefore, that is positive 200. Then it lives on the positive terminal also of 50 volts. So that is plus 50. Okay? So positive 200 plus 50. So it lives on the positive terminal of the 2 battery. Then let's have now the, the voltage drop. Take a look here, the voltage drop in the 10 ohm resistor. So tingin ha, if the current is going to the right, this is also going to the right. Okay? They have only one direction. To the right, to the right. One direction, remember that, one direction, one line. Okay? See? Take a look again. Take a look. This is to the right, to the right. To the right here. Okay? To the right also, meaning that is minus. If there is only one direction of the circuit current and the tracing, circuit tracing, they have only one direction, one line. If there are two direction, two lines. Later, we'll discuss that. Let's go first with one direction. I1 to the right. Circuit tracing to the right. So therefore, put here to the right. So meaning it is negative. Okay. So we have here 10 I1. 10 I1. Then what about here? Oh, by the way, there is a current flowing in our 5 ohm resistor. Who is this current? Actually, this current is also our I1. Take a look at my marker. This marker, this, okay, This is the arrow of the current. I will trace this one so that it will not affect its direction. Okay? So this is also our I1. That is also our I sub 1. Okay, take a look here for our I3. This is our I3. Let us trace this. Of course, only one direction flowing, I3, I3. This is I3. And what is the current flowing in the 8 ohm resistor? Of course, that is also I3. Okay, got it? So this is on this direction. Okay? Now, again, we have minus 10 I1. The current I2. Okay, let's have first our I1 here. Again, the I1 here, the 5 ohm resistor, is going to the left. The circuit tracing is always a clockwise direction. If you are to trace that, that is also going to the left, right? This is to the left, one direction, one line. Okay? One direction, one line. So therefore, it is minus 5I1. 5I1. What about for I2? I2 is going downward, then our circuit tracing is also going downward. Pababa, pababa, one direction, going down, one line. One line is negative, of course. Huh? So we have here minus 5 I2. Okay? That is equal to 0. Okay? Let us double check that. Actually, I'm doing this. This is my little secret. So, we have to take a look. We have 1, 2, 3, 4, 5. So, there should be 5 term in the equation. So, 1, 2, 3, 4, 5. Okay? So, let us now simplify this algebraically. So, we have here 250. So, negative 10, I1, this is I1, negative 10, negative 5, we have negative 15. So, we have here negative 5, I sub 2. By the way, there is I1 here. So, that is equal to 0. Let us transpose the negative 15 so that it will become 15 I1 negative will become positive, negative, positive I sub 2. So that is equal to 250. Okay? 250. I will call this as equation number 2. Okay, let's have now by Kirchhoff's voltage law at BC, BC, D, E, B. Or loop 2. Okay? That is our loop 2. Let's have first the source of EMF. Take a look here. It lives on the negative terminal of 100 volts. So, therefore, it is negative 100. It lives on the negative terminal of the 50 volts here. Okay, so doon siya lumabas sa negative terminal, ha, mga kawerpa. Pag lumabas siya sa negative terminal, negative yon. Okay? Okay, what about now the voltage drop? The voltage drop is, let's have first for the 12 ohm resistance. The circuit tracing is going to the right. That's going to the right. So that is to the right, one direction, one line. 12 I3. What about here in the 8 ohm resistance? What about in the 8 ohm resistance? That is going, current I3 is going to the left. Okay? To the left, you are to trace the circuit tracing that is also to the left. To the left, kaliwa, kaliwa, to the left, one direction, one line. So therefore, it is minus 8 I3. Okay? Now, here in the 5 ohm resistor, the circuit tracing is going upward. And the current flowing in the 5 ohm resistor is I sub 2. If the circuit tracing is going upward, that is upward. So that is upward. And the current I2 is downward. Upward, downward, two direction, two lines. Okay? So meaning it should be positive. So that is 5. That is 5 sub 2. Okay? So that is equal to 0. How many terms do we have here? 1, 2, 3, 4, 1, 2, 3, 4, 5. What about here? We have 1, 2, 3, 4, 5. So therefore, it is already complete. Now, take a look here. Let us simplify algebraically. So we have here negative 150. Okay, please focus here, your camera. Okay, plus 5 I sub 2. Okay, then this is I sub 2, this is I sub 3, I sub 3, negative 12, negative 8, that is negative 20, I sub 3. That is equal to 0. Let us simplify. So we have here 5 I sub 2 minus 20 I sub 3. That is equal to, let us transpose the negative 150 here. Negative 150, let us transpose positive. So this is our equation number 3. Okay? We have 3 unknowns. We have to make this as for our calculator so that our calculator will understand the manipulation. We have to put plus 0, I sub 3 here. So to make it I1, I2, and I3. That's complete already. What about here? There is no I1. So you have to add 0, I sub 1. Although it is also 0, right? But it is necessary in our calculator. Okay, we will not be doing determinants, we'll not be doing the Kramer's rule. No, we'll go directly with our calculator. Okay, so put your calculator in mode 5.2. Mode 5.2 lang. Okay, so we have mode 5.2. Pindot na mga kawerpa, mode 5. Mode 5. Okay, see, this is the first equation. Take a look here. You input 1 equals, and then here, that is negative 1. Input negative 1 equals, then we have here negative 1 also. Negative 1 equals, what about the D? This is actually the portion of A, B, C, and D in our calculator. So we have here 0 equals, okay. Then for equation number 2, we have here 15. Please focus here, 15 equals, so we have here 15. 5 equals, then we have here 0. 0 equals, then we have here 250. Right? 250. 250 equals. Then, equation number 3, you input 0 equals. Then we have 5 equals. Then the next is negative 20. Negative 20 equals. Then we have 150 equals. Then you press equals. Okay, so my answer here is 11.58 for our I1. I'll just put it here. So this is our I1. Our I sub 1 is equal to 11.58. I will round off into 2 decimal places. 11.58. Okay, what about our I sub 2? Another equals. Okay, there is a fraction but you have to press your SD. That is above your del. So that is 15.26. What about our I? That is negative. Negative 3.6. Negative 3.68 amperes. Okay, so these are the current. Let's see in our multiple choice, if our choices. Again, let's take a look at our I1 here. Our answer is 11.58. That is letter Okay, we will double check if answer in the PowerPoint and our answer is correct. Okay, for number 1, our answer I1 is 11.58. That is letter A. Okay, that's correct. What about for number 2? Our answer is 15.26. Yes, that's correct. That is letter C. Okay. Then our I3 is negative 3.68. Okay, letter B. That's correct. Okay? Nakasunod ba mga kawerpa? Nakasunod? Okay. Sige, kung hindi, marami pa tayong example. Masusundan nyo yan. Okay. So, the next question is number 4. What is our voltage at A to D? What is the voltage at A to D? Take a look here. I will not erase the circuit, of course. I will just erase some portion. Anyway, you can watch this again in YouTube, our lecture, so that you can copy everything what I've written on the board. Let us go with voltage at AD. That is the question here. Let's take a look for number 4. The voltage at A to D. So we have the following choices: 191, 166, 180, 171. How to get the voltage at AD? We have to put a voltmeter here, VAD. Put it here at point A going to point B. Then let us assume the positive and negative terminal of the voltmeter. Okay? There are many ways in solving this question, this problem. We have to consider a certain loop, and we'll be using the Kirchhoff's voltage law. Take a look here. We can consider A, B, C, D, and of course the voltmeter. Let's do it. Okay, I will put it here. I will draw the from point to B. There is a 10 ohm resistor. Point A to B, meron tayong 10 ohm. From B to C, we have the 12 ohm resistor. Okay. From C to D, there is a voltage source, 100 volts. Okay. Let's say this is our point A, point B, point C. At point C, the positive terminal of 100 volt is connected to it. So that is a positive and negative. Positive, and the negative terminal is connected to point P. This is our point P. Okay, so let us have here our voltmeter. This is our VAD. Okay. So let us have now the current. The assumed direction of current must not be affected. It must not be affected. You assume from point A to point B. For I1, it will not change. Of course, that is still from point A to point B, put here I1. What about here? From B to C, we have I sub 3. B to C, we have I sub 3. Okay? And then we have, anyway, this is just a voltage source. So, we can now, this is the 100 volts source. Let us have our tracing. Remember, this is the positive terminal and negative terminal of the voltmeter. We have a voltmeter here. Okay, let us have the circuit tracing like this one. Always a clockwise direction. Let's have first for the voltages. By the Kirchhoff's voltage law, it leaves, the circuit tracing lives on the positive terminal of the voltmeter. So therefore, it is positive VAD. Okay, so doon siya lumabas sa positive terminal, ha, mga kawerpa. Pag lumabas sa positive terminal, positive VAD. Okay? What about the 100 volts? It lives on the negative terminal. So that is why that is negative 100 volts. O, mga kawerpa, lumabas sa negative terminal. Kaya, negative 100 volts. Okay. Punta tayo sa voltage drop. Voltage drop, take a look here at our circuit tracing on a clockwise direction. Always clockwise ang ina-assume ko dyan. So this is going, I1 is to the right, and then the circuit tracing is to the right. So, to the right, to the right, to the right. See? One direction, one line. So that is 10 I1. Okay? So 10 I1. What about here? This is to the right also. To the right, one direction, one line. So that is 12 I sub 3. So that is equal to 0. There are how many terms? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Meaning it's complete. Because when I was a student, I always see to it that I'm checking my work. When I lock the padlock of our door, I see to it that I I double check it or triple check or 4, 5. See to it that it is locked. See, when I lock the door of my car, I see to it that many times I really see to it that I'm always doing some double checking, triple checking, even many times of checking. Always in my job or in my only in my job in all aspects of my life, I always see to it that I'm checking. Always. Okay? So, just like in here, we have to check our word because the positive becomes negative, everything is wrong. See? That's how important checking is. Okay? So, always check your word in all aspects of life. That's very important. We have to check everything. Okay. So, we have BAD minus 100 minus 10 times what is our I sub 1? That is 11.58, then minus 12, then multiplied by negative 3.68. That is equal to? Okay, that is 0. We just have to manipulate this in our calculator. Use your calculator. Okay, my answer here is 171.64. 171.64 volts. That is my answer. Okay? Take a look here. Okay, so the answer would be letter D. See? 171.64. Okay? What is the other way? Can we check our answer by the way for the current? Take a look here. How sure are we that this is the exact value? How to check? How to check? Just check. Okay? Want to check? Just check. Really? Of course not. Okay, so take a look here. We have here our I sub 1 at node B. Let's say to check. I always do this when I solve problems. I really find way to check my answer. If our examination is one and a half hour and I already finished 1 hour, I will not submit yet my paper. No, I'm not like that. I'm not a student like my classmates. No? They want to submit early and so that they can go early to the mall. See, I'm not that kind of student. I always check my solutions, my answer. I'm very meticulous in solving problems. Take a look here. To check, anyway, we already have the equation by Kirchhoff current law. The current entering is equal to the current leaving. That is the summary. I1 will be equal to I2 plus I3. Okay, what is our I1? That is 11.58. Is that equal to I2, which is 15.26? By the way, that is plus, take Take note that this is 3.68. Are they equal, yes or no? Let us use our calcu. Yes, the same. Exactly the same. Therefore, check. Okay, that's one way of checking. Sir, by the way, what do you mean by negative current? What do you mean by negative current? Ano ibig sabihin ng negative, sir? Take a look. Actually, this is already given in the problem that the direction of I3 is going to the right. Okay, there is an assumed direction. Let's follow the assumed direction. Again, I always assume clockwise direction for the circuit tracing. Okay? What do you mean by negative direction? Negative direction means wrong assumption of the direction. There is a wrong assumption. So, mali ang assumed direction. Instead of going to the right, actual direction of the current is going to the left. Okay? Well, anyway, in calculating the voltage at AD, we have to consider still the negative. You see, I consider the negative as it is. Your calculated value must prevail. You have to consider that. Sir, is there any way to check this? Yes. So just check. Okay? No, that's not the way of checking. How, sir? I consider the upstream here. I will call this as the upstream. Yan, yun nasa taas. Upstream. I will consider the downstream here. The downstream circuit. Take a look here. So I consider this as a circuit path because the summation of voltages around any loop is always equal to 0. So I made a complete loop. One complete loop. I will make again a complete loop considering the downstream. A, F, E, F. ED, I mean. Okay. So, let us consider our point A here. Okay, I will just draw the circuit. A is connected to the positive of the 200 volt source. Then the negative is connected to point F. And then point F, there is a resistor here. It is 5 ohm resistor. Okay. So after the 5 ohm, there is point E here, point E, and then we have here 8 ohm resistor, then we have point E. See, I already traced. Again, please listen carefully, everybody. Okay, so we have here our 200 volt source. This is the 200 volt source. From A going to F, there is a 200 volt source. From F going to A, there is a 5 ohm resistor. There is a current flowing. That is our I sub 1. Our I sub 1 is going to point F. This is our I sub 1. The direction remains the same. You should not change the direction, the assumed direction of the current. That is the given in the problem. Do not change that. Okay? Let's go over with I sub 3. That is towards point E. So, wag niyong iibahin yung direction, ha? Yun pa rin yun. So, ano to? I sub 3. There you are. Now, I will put the voltmeter over here. Okay, so that is the voltmeter. Let's call it VAD. VAD. This is the positive, this is the negative terminal. Then I will put the circuit tracing on this direction, always in a clockwise direction. Okay, again, let us have the Kirchhoff's voltage law. Let's go over here. By Kirchhoff's voltage law. Take a look here, guys. Take a look. It lives on the positive terminal of PAD, therefore, that is positive PAD. Then it lives, the circuit tracing lives on the negative terminal of the battery, so therefore, it is 200 volts, negative. Okay? Negative 200 volts. This is going to the right for the 5 ohm resistor. And the current in the 5 ohm resistor is I1. That is going to the left. To the left, to the right. To the left, to the right. Okay? To the left, to the left. Okay? So, dalawang direction. It has two directions. To the left, to the right, there should be two lines. 1, 2. You see? That is a plus sign because there are two directions. What about here? Please listen, I am building the foundation first. Okay? Please listen carefully. Our circuit tracing is going to the right. This is to the right, and I sub 3 is to the left. Okay? Again, to the right, to the left. Two direction, two lines. Okay? Oh, by the way, I have to put here first our 5 I sub 1. Okay? Again, the circuit tracing is to the right, I sub 3 is to the left. So therefore, two direction, two lines. This is 8 I sub 3. That is equal to 0. So we just have to substitute minus 200 plus 5 times I sub 1 is 11.58. So this is 11.58. Then plus 8 times I sub 3, carry over the sign, that is 3.68. That is equal to 0. Okay, let us solve now V. Okay, please focus here. Okay, my answer here is 171.54. 171.54 volts. Sir, you are wrong. My student said that. Why? Because here, this is 171.64. Your answer here is 171.54. You're too much meticulous. Too much meticulous is wrong. No? But if you want to become the deepest of the meticulous, you should know that there are rounding off. You see, what you see is the very small difference, but you did not see the whole number here. That's unfair. Right? Nakita mo yung maliit, napakaliit na diferensya. Yung malaking pagkakapareho, hindi mo nakita. See? Okay? There's another way of doing it so that you will appreciate this lesson. Take a look. I consider the upstream. I consider the downstream. Now, I will consider the middle stream. If we can call it the middle stream, this portion. Okay? I will consider A, B, E, D. Tingnan na lang natin. No, kung di pa kita makonvince dyan. So, A, B, E, D. I will have my circuit tracing. Okay. I will erase this portion first. I will not erase our final answer for the upstream. I'll just use my space here. Oh, gising pa ba kayo dyan, mga kawerpa? Nakikinig ba kayo dyan? Hear you. Let me hear you.
Yes, sir. Gising pa.
Yes, sir.
Okay.
Yes, sir.
So, let's have the circuit tracing. I will use A, B, E, D. A, B, E, D. Oh, take a look, ha? Tingin tayo, mga kawerpa. Gising. Oh, ito, ha? Point A, then we have 10 ohms. Let's say this is our point B. The point B is connected to the 5 ohm resistor. There is a 5 ohm resistor and that is connected to the negative of the 50 volts and the positive of the 50 volts is connected to point B. And point B is connected to 8 ohm resistor, 8 ohm resistor, then to point B. Okay, what about the assumed current? From A to B, we have I sub 1. Okay, from B to E, we have I sub 2. From B going to E, I sub 2. Okay, so what about here from E to D? Okay, the direction of I3 pointing to letter E. Okay, it should have the same current, not be affected. Okay. Again, let us put our voltmeter VAD to this terminal and to this terminal. This is positive, this is negative. And I will have the circuit tracing always on a clockwise direction. Always on a clockwise direction. Again, by Kirchhoff's voltage law, by Kirchhoff's voltage law. Take a look. The circuit tracing, please listen. Please listen. This is a hard thing to do. Okay? Please listen carefully. Please be cooperative, everybody. If the circuit tracing leaves the positive terminal of the voltmeter AD, therefore that is positive VAD. What about the voltage source? It lives on the positive 50. So doon siya lumabas sa positive 50. So therefore, plus 50. Okay? Now, what about the voltage drop? For the 10 ohm resistor, so this is going to the right, one direction, one line. That is 10 I sub 1. I2 is to the right, then the circuit tracing is to the right also. So therefore, this is to the right also. Okay? Pakaliwa, pakaliwa, pakaliwa. Okay? So we have here 5 I sub 2. Okay, what about here in the 8 ohm resistor? This is going to the left. Okay? To the left, to the right, direction, 1, 2, 2 lines. Meaning it is positive. Okay? Dalawang direksyon, dalawang guhit. No? Positive yon. So we have here 8 I sub 3. Please listen carefully. I will assure you, I've watched a lot of lecture in the YouTube about Kirchhoff law. I will assure you that this is the clearest discussion of Kirchhoff law. Whoever you are, whether you are American, Filipino, European, Asian, African, I will assure you, you will understand this lecture. You just have to listen carefully. Okay? I saw some lecture, they pronounce it's very hard to understand pronunciation. You cannot comprehend, and their approach in the solution is very hard to comprehend. It's very hard. We we will try our best to simplify everything. Okay? So please listen carefully. So we have here VAE. Let us just substitute plus 50 minus 10 times I sub 1. What is I sub 1? 11.58 minus 5 times I sub 2, 15.26 plus 8 times okay, I sub 3, negative 3.68, that is equal to 0. Okay, let us solve. How much is this? Okay, I got exactly 171.4. See in my calculator? See? Well, I have to transpose so that it become positive. Okay? The answer is 171.54. See? I have the same answer. Any loop, this proves Kirchhoff's law is correct. No, it's really correct. The Kirchhoff's law. Sorry, not Kirchhoff's. Kirchhoff's. Okay? Sir, I still don't believe. You don't believe? You better open the window of the building. Then you, well, talk only. Okay. Okay. So, we will go now to the next problem. This is a past board exam problem. Okay, let us continue. Let us continue. In the DC circuit shown, so this is now the figure, the high resistance voltmeter gives a reading of positive 0.5 volt. What is the value of resistance R? Is the question. We already have the reading of the voltmeter. So let us redraw the circuit. I will just draw the equivalent circuit when you remove this voltmeter. Well, voltmeter is just being tapped in the circuit, right? I will just remove that voltmeter. I will remove the voltmeter. It just so happened that when you put your voltmeter terminal, this is the red one and this is the black one. Okay? This is just a voltmeter. Just like the one I have. Okay? See, there is a voltmeter. Of course, you have to put this in the DC volt. There is a DC volts in my meter. Then I put the positive, the red one is the positive terminal, and the black lead is the negative terminal. Then I will just remove this. Okay? I will remove this. So, this is now our equivalent circuit. Okay, this is our R, our 20, this is 50, this is 10 ohms, then there is a voltage source here, 12. Okay, so we have 12 volts source. Take a look here, guys. Let us have a current. This is our I1. This is our I2. Well, the voltmeter is just being tapped at this point. Let's say this is our point A. And then this is our point B. Okay? You just tap. Then I remove the voltmeter. So we have here our 1. What is now the equation for I sub 1 first? I sub 1, please listen carefully. This is a board exam problem. Okay? So, what is I sub 1? Well, this is easy. As simple as Ohm's law. I1 simply equal, what is the voltage here? Of course, this is a purely parallel circuit. The voltage here is equal to the voltage here and equal to the voltage here. Okay? So we have here 12 volts. Ohm's law is the current is voltage over the resistance. What is the resistance? Of course, the series combination of R plus the 20. Okay? Then let's have now our I sub 2. We have here 12. Again, we have 12 over the combination of 10 and 50. So we have 10 plus 50. We can solve this. So this is 0.2, 0.2 ampere. We cannot solve this because R is unknown. That is the unknown in our problem. Now, we have I1 and I2. Take a look here. This is I1. This is I2. Then I will bring back the voltmeter. I will put again in point and in point there is a positive and negative terminal. I will have a circuit. Only one loop. See? That is a clockwise direction. On the upper loop here, let us make use of the Kirchhoff voltage law. By the Kirchhoff's voltage law, take a look here. So, tingin mga ka-aware pa ha. Uunahin ko yung voltmeter. For the voltmeter, the circuit tracing, again, that is assumed to be clockwise. It lives on the positive terminal of the voltmeter. The positive terminal of the voltmeter. So therefore, that is positive V. Anyway, we have already a value of positive 0.435. 0.435 volt. That is positive. What about here for R? For R, I1 is the current flowing through R. That is downward. And then the circuit tracing is upward. So this is downward, upward, two direction, two lines. Okay? So we have I1 or R. So I'll put first our R and then our I1. What is our I1? 12 over R plus 20. Okay? What about for 10 ohm resistor? 10 ohm is downward, circuit tracing is downward. Pababa, pababa, pababa. Downward, downward. One line, there's one direction, there should be one line only. 10 multiplied by 0.2. That is equal to 0. As you see here, there is only one unknown. Okay? Well, in our calculator, that is simply shift solve, right? It's a simple shift solve. Okay, so, but let us manipulate this algebraically. Let us combine okay, so the negative 10 times 0.2 then plus 0.435, that is negative 1.565. Okay, let us transpose this. So we have here 12R over R plus 20. So that is equal to okay, so we have R equal to 1.565, then R plus 20. So we have here 12R, that is equal to 1.565 R. That is plus, let us just distribute this. So 20. That is 31.3. Let us transpose this. So that will become 12 minus this is 10.435 or is equal to 31.3. You see, I just simplify this. I just simplify 12 minus 1.565. That will become 10.435 R is equal to 31.3. So just have to divide the 31.3 by 10.435. Our answer is 2.9950843 or just simply 3 ohms. Okay, I just showed to you a long method here. Well, of course, in our calculator, we can stop here. In our calculator, then you just have to shift solve in our calculator. By the way, to our new viewers, we are using the calculator of Casio 991 ES Plus. You can also use the 570. This is Casio 991 ES Plus. You can also use the Casio 570 ES Plus. Okay. And you can also use the 570 ES Plus second edition, the color black. The, the 991, the 570 ES Plus is just the same. No? Their only difference is the solar power here. The solar power here. Okay? Just like this one. That is the 570. Okay? Okay, that is the answer in the past board exam problem. Okay. To our non-Filipino friends, when I say past board exam problem, so this is being given in the licensure exam here in the Philippines. No problem because what's important is for you to understand the uh, principles, the concept. Okay, it's just that I gave an example that was given in the licensure exam. Okay, what's important is the concept of what we are doing, the principle, so that any question your professor will give to you, you may answer it easily because you know the principle. Okay, let's go over with the last problem. This is the last problem, but it has 5 questions. Okay, so let us start here. Actually, this is just part one of the Kirchhoff's law. There is still part two. I will be discussing that on Monday. Today is Friday, right? In our country, that is Friday. That is almost 11 a.m. Okay, I will redraw our circuit anyway. So you just copy. Okay, so let's have now problems. This is from 6 to 10. I already draw the circuit on the board. In here, the problem is all the current. Let's take a look at the current. So the current is I1. So we have I1, I2, I3. So there is I4. I4 is going down here. This is I4. Then we have our I5. Take a look here for our I4, guys. I5. I will go first with I5. What is our I5 here? Because we will solve this as I1, 2, 3, I4, and I5. There are so many equations that will become 5 equations. That is too long. Ubos ang oras mo sa board exam. That is too long. We will reduce the unknown to 3 only. Instead of 5 unknowns, I will make it 3 unknowns only. How to do it, sir? We will make use of the Kirchhoff's current law. The Kirchhoff's current law. We have node A. We have node B. Is this a node? Is this a node? Is this a node? The answer is no. Because there is no separation or the current does not divide. The current flowing here is I3 and also this is also I3. There is no division of the current. Unlike at node A, I1 divide into I2 and I4. So therefore, this is a node. This is node. Okay. Let us have at node B by Kirchhoff current law. What is our I5 here? Take a look. What is our I5? Our I5 is the current entering is equal to the current leaving, isn't it? So this is I2 plus I3. That will be your I5, right? So therefore, this current, this I5 is simply equal to, I'll just put it in here, that is I2 plus I3. Okay? What about now for I4? Okay, I will replace I4 here. What is the value of I4 by Kirchhoff current law at node A? Take a look. I will put here as a scratch solution. So, we have here I1. I1 is equal to, the current entering is equal to the current leaving. The current leaving is I4 plus I2. So, what is our I4 equal to? That is equal to I1 minus I2. So, let us put here I1 minus I2. That is our I4 already. Makinig mabuti ha. Mamali ka lang ng sign. Mali ka na lahat. Please listen carefully. So we have here I1 minus I2. Okay? I1 minus I2, that is our I4. Okay? So we have here circuit tracing. I will introduce a circuit tracing for loop number 1, for loop number 2, for loop number 3. There are 3 loops now. This is harder to solve compared to the first problem. Okay? So let us have by Kirchhoff's voltage law. By Kirchhoff's voltage law. At, let's say, loop 1. Let us treat this as loop 1, loop 2, and loop 3. Tingin tayo sa loop 1. Look. This is again a circuit tracing. The circuit tracing lives on the positive terminal of 6 volts. Therefore, that is positive 6. See? So, positive 6. What about here? The voltage drop in the 6 ohm resistor. The circuit tracing is going to the right. To the right, the current I1 is also to the right. There is only one direction, therefore one line. So that is 6 I1. Okay? So that is 6 I1. What about in the 3 ohm resistor? The current I4 is going downward. So, the circuit tracing is also going downward. So, parehas sila, pababa. One line, there should be one line because they have one direction. Minus 3 I4, or I will just put here I1 minus I2. Okay? So that is equal to 0 because there are 3 terms. There will be 3 terms. So we have 1, 2, 3. 1, 2, 3. Voltage source 1. Voltage drop 2 and 3. 1, 2, 3. 1, 2, 3. So therefore it's complete already. Let us simplify. So we have here 6 minus 6 I1. So distribute. Let us distribute this. So this is negative 3. That is negative 3 I sub 1. Negative, negative, positive 3 I sub 2. That is equal to 0. Okay, let us simplify. This is negative 6. We have I1 here. We have I1. So that is negative 9. I1. And then we have plus 3 I sub 2. Okay. Then we still have our 6 volts here. So there is positive 6 volts here. So that is equal to 0. Now let us transpose the negative I1. I don't want to see any negative sign. I don't want to see negative. Okay? I will make it positive. Okay. So we have here, let us transpose the negative 9 I1. So that will become positive. Negative will become positive. So that is positive 9 I1. Okay? I transpose this. Positive 9 I1. Okay, no choice. This is positive will become negative 3 I2. So 3 I. Well, there is no I3 portion here. I will put here for our calculator, I will put here 0 I3. So that is equal to 6. So this is our equation number 1. Equation number 1. Let's have now by Kirchhoff's voltage law at loop 2. Take a look here at loop 2. O, tingin, mga ka-aware pa. Dito tayo sa loop 2. The circuit tracing lives on the positive terminal. 5 volts. Okay? So, lumabas dito sa positive, ha? So, therefore, positive 5. What about the voltage drop? We have here. This is the voltage drop here. The current I2 is going to the right. And this circuit tracing is, if you are to trace, that is also going to the right. Right? Okay, only one direction. To the right, to the right, to the right. So that is 2 I2. What about the 4 ohm resistor? I5 is downward. The circuit tracing is also downward. Downward, downward, one direction, one line. Then 4 I5. By the way, what is our I5? There you are. So we have here I2 plus I3. For the 3 ohm resistor, take a look here. The current I4 is flowing through the 3 ohm resistor. That is downward. Downward. But the circuit tracing is upward. Upward, downward. Upward, downward, direction, 2 line. So we have 3 multiplied by I4, which is I1 minus I2. So that is equal to 0. How many terms do we have? 1, 2, 3, 4. Okay, so we have here 1, 2, 3, 4. Therefore, it's complete. Let's just simplify. So we have 5 minus 2 I minus, let us just distribute this. Negative 4 here and here. So this is a negative 4 I2, then negative 4 I3. Then what about here? Let us distribute the 3 here. Then we have plus 3 I1. Okay? Plus 3 I1. What about here? Minus 3 I2. That is equal to 0. Okay, let us simplify further. We have 5. We have I1. Okay, we only have 3 I1. 3 I1. What about for I2? By the way, we have I2 here. 1, 2, 3. So this negative 2 minus 4, that's negative 6. Negative 6. And negative 9. That should be negative 9 I sub 2. Okay? Then we have negative 4 minus 4 I sub 3. That is equal to 0. See? We have 5, 3 I sub 1. Then we have negative 9 I sub 2. Then we have negative 4 I sub 3. Okay? So let us continue. Let us reduce the negativity. Okay? So I will just transpose. I will transpose what? I will transpose this. Positive 3. I said I reduced, but this becomes negative. Okay. So this is negative 3 I sub 1. But two negativity here. Okay. This negative I will transpose. That will become positive. Negative will become positive 9 I sub 2. Then negative will become positive 4 I sub 3. Okay? Negative, negative will become positive and positive. Okay? Then that is equal to 5. So we already have equation number 2. Okay? One more equation. Then that will be easy. Just simply mode 5-2, right? Okay. By Kirchhoff's voltage law, at loop 3. Actually, we are virgin one stone. The purpose of this is for the college exam and also for our students. There are students listening or viewing us or watching us. Also for board examination or licensure exam. You can use this. Take a look here. At loop number 2. For loop 3, we have the circuit tracing here. It leaves on the negative terminal, therefore negative 10. What about here in the 4-ohm resistor? That is going to the left, and this is going to the right. Left, right, two direction, two line. So we have here 4 I sub 3. Here. What about in the 4-ohm resistor here? The tracing is going upward. Upward. The tracing is upward. But the current is downward. Upward, and this is downward. Two direction, two lines. 4 multiplied by I5. Or I5 is simply I2 plus I sub 3. So that is equal to 0. Therefore, we have 1, 2, 3 parts. There should be 3 terms. 1, 2, 3 terms. Okay, that's complete already. Let us simplify further. So we have negative 10 plus 4 I sub 3. Let us just distribute this here. So we have here plus 4 plus 4 I sub 2 plus 4 I sub 3, that is equal to 0. Okay, let us simplify. Since there is no I sub 1, I will put here 0 I sub 1. What about our I sub 2? Plus 4 I sub 2. What about for I sub 3? This is I sub 3, this is I sub 3. So that will become 8 I sub 3. So that is equal to 10. So that will be our equation number 3. Now we are ready. Come on. Okay. So we have mode 5-2 in our calculator. Okay, by the way, I'm thinking of our new viewers. So we are using Casio 991 ES Plus. Well, in the licensure exam here in the Philippines, so before it was allowed, 2010, but just last year it was not allowed by the Professional Regulation Commission. But there is the same model known as the 570 ES Plus. Just the same, the only difference is the solar power here, but the function, in fact, they have only one manual. There's only one manual. Iisa lang ang manual nito. Pag bumili ka ng 991, yun din ang manual ni 570. Kasulat yun doon. Okay. So that it will not take it too long, no? Solving the currents. So we'll just make use of our calculator. Pressure calculator. Mode 5-2. Take a look at our equation numbers 1, 2, and 3. So this will be our reference. Look here. Tingnan, mga kawerpa. So put here 9 equals. Pindot nyo na ba? Mode 5-2. Pindutin nyo muna. Mode 5-2. Then you press now. Here from left to right. Take a look at the numerical coefficient. 9 equals. Then we have here negative 3 equals. Then 0 equals. Then 6 equals. Then let's go to equation number 2. Negative 3 equals. Then we have 9 equals. 4 equals. 5 equals. Equation number 3. 0 equals. 4 equals. 8 equals. Then we have 10 equals. Then you press now equals. What will be the value of x? Pakita nga natin, tingnan natin kung may nakakasunod sa atin. Meron bang nakuha kong x 7 over 9. Sino ba ang nakakuha ng 7 over 9? Taas nga ang kamay. Thumbs up nga kung nakuha nyo 7 over 9. Thumbs up. Okay. Sige. Si ano nagtataas ng kamay? Ayan pa, si Ricky nakuha din. O sige, kayo magbigay ng value sa akin. Tingnan natin ha kung parehas tayo sa Y at sa Z. Once you press the mode 5.2, yung binanggit ko kanina, already input all the coefficients. What is our X? Okay, I will call, sana maayos yung audio ninyo, papakita ko kayo sa YouTube. Si Ricky Riveza, thumbs up siya. Ricky, can I hear you? So that our audience or our viewers, they can see that is an interactive class. This is not only being recorded in the studio. It is just being on a live, a virtual classroom we have here. Ricky, do you hear me? Hindi yata tayo naririnig. Si Roy Vincent, naririnig mo ako Roy? Pwede ka bang mag-unmute? Ano yung value ng X mo, Roy? Unmute siya, paki-unmute.
0.78 or 7 over 9.
Pakilakas yung process, Roy. Ayan. Please speak louder.
0.78 ampere.
Ano daw?
78 ampere or 7 over 9.
Ay, relax muna, relax. Yung X muna. Ilan yung X mo? Pakilakas. Ilan yung X mo? Sino pa po nakakuha? Sino pa nakakuha? The X is... Ayan, Leo, ikaw na lang, Leo, kasi hindi maayos yung audio ni ano eh. Yung isa. Ikaw na lang, Leo. What is the value for X? Ito yata.
X is 7, 9.
Ha? 7 over 9, Leo, tama ba?
Yes, sir.
Okay.
And, Y is 1 over 3.
Audio niya. Your X is 7 over 9, Leo?
Yes, sir.
And
Yes,
what
sir.
is your Y?
And my Y
Another
is 1
equals.
over
Pindutin
3.
mo lang, equals.
Yes, my Y is 1 over 3.
1 over 3.
My Y, yes, sir.
What is your Z?
And my Z is
Not your Y. Your
Z
Y.
is
What is your Z?
my Z is 13 over 12. 13 over 12, sir.
13 over
Hello, sir. 12.
12. 13 over 12. Let's see if Leo is correct.
12.
Let's see. So this is a live audience to our viewers. Our X is our I1. Our Y is our
Okay.
I2. And this is our I3. Let's see. This is our I3. Okay, so we have here number 6. Take a look. Leo's answer is 7 over 9. What letter is that? Let's see, there should be the animation, Leo. Okay, that's correct. No? Labang palakpakan dyan. Palakpakan naman. Yun, yeah, tama. Okay. What about for number 7, I said 2. Leo's answer is 1/3. Let's see. Yun, tama na naman. Okay. For number 8, I said 3. What is Leo's answer? I sub 3. Yun! Tama na
13/12.
naman. 13 over 12. So that is Leo's answer. Okay, Leo, very good. No? So you know already how to use our calculator. Okay? To our non-Filipino audience, don't worry because we are just using this calculator here in the Philippines because this is allowed by our Professional Regulation Commission, the one conducting the licensure exam. It's like a state board in the US. Okay? We call this in the Philippines as a board examinations or licensure exam, like a state board. Okay? I know in US they have the professional engineers state board exam. It's like that here in our country in the Philippines. So this is luckily this is allowed. Well, of course, if it depends on the calculator in your country, no, what model is allowed in your country, so there'd be no problem. And I believe that this is also available all over the world. This calculator, not only in our country, because Casio is worldwide. This is the brand is Casio. Okay. Anyway, we still have to calculate for I sub 4. Okay, ah. Let's go with I sub 4. We said that I sub 4 is I1 minus I2. Let's see. What is our I1? Ito natin agad sa calculus. What is I1? 7/9. Okay, then subtract 1/3. So the answer is 4/9. Let's have our PowerPoint. 4/9, is that correct? Is that letter C? Let's see. Tingnan natin mga kawerpa. Yes, that's correct. Okay, last number. Our number 5 is I2 plus I sub 3. That is equal to what? O, tingin mga kawerpa. Ha? What is our I2? 1/3. Okay, then we have plus 13 over. So that is 17/12. That's the answer. Of course, all are in amperes. 4/9. Last number, we have 17/12. Okay? This one. 17/12. Okay, so therefore, we have a correct answer on our board. To our non-Filipino friends, no? So, you are a multiple choice type of question because this is the format in our licensure exam. So, it is purely multiple choice. From time to time, we'll be discussing all the problem in multiple choice form. Well, I think one of the advantage is you can be assured that your answer is correct if that is found in the choices. That is one assurance. Although I would say not 100%. No? Of course, you have to make some checking, just like what I've said before. You have to check your methods, your techniques. No? Of course, even your solution, just in case the positive sign you made is as negative, of course the entire solution will be wrong. That's how mathematics is. That's how delicate mathematics is. Okay, so you have to be very meticulous. You have to be very meticulous in solving problems. Okay. It's not like pronunciation. Sometimes you can say a wrong pronunciation or wrong grammar. So well, that's okay. That's fine. Sometimes it doesn't change the sense of the statement as long you may correct it easily. Okay, but in here you have to double check step. Very important to double check every answer, every part of the solution. You have to double check, triple check. Okay, you have to be wise in solving these problems. Okay, any question? No, I think I am done with our first topic of Kirchhoff. There is a second topic, and that will be on Monday. Okay, to our viewers, to our friend in our Zoom class. Oh, by the way, before you leave, to all our viewers in the YouTube live stream and also to our Zoom class participants. Okay, so please do not forget your comment to put that will be part of your attendance. Okay, so put your comment in the comment section in the YouTube once we upload this. Actually, we can put comment now, right? Because this is on a live stream. Right? Tama? Pwede na silang mag-comment doon. Live stream ito eh. So you can put to our Filipino friends, no, if there are watching. Of course, uh, bago pa lang tayo, hindi pa tayo masyado pinapanood. No? Pero i-upload natin ito. Malay natin, meron tayo mga African nanonood, Pakistani, Indian, what, whatever races you have. No, there is no problem because our intention is to help the students even the examination, licensure, or state board exam all over the world. No? We want to help you guys. That's why we are exerting a lot of effort doing this. I'm quite sad because when I browse in the YouTube, there are many people or teachers. They don't discuss that well topic. Uh, uh, there are some discussing too fast. The student cannot catch up, because they solve it too fast. Then I saw the English pronunciation is very hard to comprehend because I think they are not English speaking country, so it's very hard. Their tongue is it's very hard to catch up their pronunciation. Well, that is a little advantage here in our country, the Philippines. Many people speak English language, although we are not that fluent. We are not that great in speaking the language. No, uh, it's just that clarity is very important when teaching. Clarity and the step by step. And then I saw in the YouTube that he teaches too fast. And he he did not he is not teaching that detail. No, I find sad. I feel sad for the students. What more in a country, let's say in a certain country, their teacher is not teaching that well. Of course, the student. Sometimes we have a great teacher, but still the student don't listen. You have to do something, teacher. So this is our part. This is our part to the world. We want to help all the electrical students or examiners who will take the licensure exam, the board examinations. Okay, so we are happy that we are the only one. I think, but that should not be a reason for us to become boastful. Of course not. Of course not. Our intention is to help. We are doing this a very hard. This is a very hard for us because this is not setting this kind of setup wherein there are students listening in the Zoom. They can ask question. Okay, so this is not easy. I never seen in the YouTube like this setup. We are the only one in the field. I say, I am only particular in the field of electrical engineering education. I, I, I don't know in the other field if they have this kind of setup. Okay, by the way, before we leave to our Filipino audience in our Zoom class, so please highlight, please spotlight them. Aris, do you have any question? Our student message us that they are in the live stream of YouTube because they are disconnected in our Zoom. So, and then, any question? Nandiyan ba si Aris? Wala. Disconnected na rin si Aris. Nawala na rin si Aris. How we wish that there are 500 participants there. No? So, anyway, let's continue serving our friends, our viewers, our students. Any question? Would like to ask question? Please speak in English. Huh? Sir Garcia, do you have a question? No question. Ayaw nyo lang yata mag-English, sir eh. English
No, sir.
tayo, ha?
I can
Walang
follow, sir. I can follow
Yes.
the lecture, sir. I am following the lecture, sir.
Sir, di ka marinig.
Sir, I can follow the lecture that you are given to us.
You can follow the lecture.
Yes, sir. It's clear for me, sir.
It's clear.
Opo. It's a big help. It's a big help for me, sir. As
Is this being taught
aspirant.
by, is this way of giving the lecture, I deliver the lecture, have you seen like this before in your teacher?
Not yet, sir. Maybe have, sir.
Okay. Thank you. Let's go with Leo. Leo, do you have any
Sir,
question?
I have one question for this
Yes, yes.
application of this Kirchhoff's law.
What?
If this Kirchhoff's law is the same as on the protection on the differential protection, sir. The for the relay protection relay.
Yes. I remember when I attended a power system engineering class. No, that is a protective relay class. I remember we use the Kirchhoff current law there. The Kirchhoff current. That's one of the application. What about Leo?
Yep. Actually, I'm doing the test, and now I can recall that the differential protection is look like the principles of Kirchhoff's law.
Yes, yes. So that may be that can be applied in the protection engineering, to be specific in the protective relaying. Yes, that's a good point of view, Leo. What else? Do you have any more question? You have a question? Leo? May tanong ka ba?
Okay, it's okay, sir. It's okay. It's clear now, sir.
Wala ka ng tanong?
None, sir.
Wala na.
It's
Okay, what is your comment about what we are doing here? So, yung ating ginagawa na to, mag-English ka, ha? What is your comment?
Well, the explanation is very clear, and as a student, we can follow the way you explain, and the techniques is very useful, and it is easy for us to review and to answer any Kirchhoff's problems based on your explanations. That's what my perceptions on how you elaborate the problems.
Okay? Anything? Leo, want to
Nothing, sir. It's
say? Okay, thank you, thank you. Appreciate it.
Excuse me, sir.
So,
Excuse po. I have a question.
who is that? Okay. Let's see, what's his name?
Uh,
Cedrix. Cedrix.
yes,
Tama ba?
sir.
Sige, anong tanong mo,
I have
Cedrix? Anong course mo
yes,
muna, Cedrix?
Shedex. BTED po, sir.
Anong course mo ulit? What is your course?
BTET.
What is that?
BTET, sir. Electrical
What course?
Engineering Technology.
Okay. BSET.
No, Bachelor of Technology, major
Bachelor.
in Electrical Engineering Technology.
You already a graduate? Are you already a graduate?
I have yes, sir. Yes, sir.
Okay. So
Yes,
are you
sir.
already a licensed master electrician? Not yet.
Not yet, but last time, unfortunately, I
Did not
failed, but
pass.
I tried. Yes, yes. But
Okay.
I will try
Problem.
this
No.
coming April.
Okay, no problem. Okay, so we can help you. We have a
I
review
have
program.
yes.
Okay, later I will talk to you, huh? Anyway, we'll be having a free master electrician fundamental course. I will announce it right after. Okay, what is your question first?
When is the best time when can we apply the for principles of Kirchhoff's law? Oh, how know if that is the best uh, formula that we can use or to when we have problem um, meet like that. When is the best time, sir?
Lugay mo, taglist mo. Sige, taglist mo. Sige, itaglist mo siya. Di marinig. Mag-unmute. Unmute ka.
Hello, sir. Hello. Yan po.
Yes, yes.
Uh, when is the best time po na pwedeng gamitin yung Kirchhoff's law?
When is the best time?
For protection po ba? Or for testing?
Well, it depends on your application. When is the best time? I think it's not the question of the time. It's the question of which area of electrical
Or
engineering are you going to use.
okay.
Well, that is one specific area. Like what Leo said before, it can be used in the differential protection. Okay. Well, we will go there.
Oh,
I will have a free webinar on protective relaying. I will have. They say that the bird does not electrocuted in the lines because there is a zero potential. They made use of the Kirchhoff's law there because there is zero potential or Ohm's law. There is zero potential. Well, it depends on the application. It's not a question of the time. It depends on the what specific areas or that's it. The application where you apply the Kirchhoff's law.
sir. Okay po. Thank you, sir.
Many students are asking. I'm just wondering they ask this to me. I'm not talking of anybody here. No? I just remember one of my student. He was a third year college then when I teach this Kirchhoff law, the mesh analysis, the Thevenin's, Norton's theorem. Where is the application of that, sir, in actual life? Of course, I gave my honest answer. Then the student will ask that, sir, where is that specific in our job? We can use that. Well, I give my answers. Okay, Thevenin's Nortons can be applied in electronic circuits, like that. So I gave my answer. I think that one student is not yet contented. The one asking is not still contented until I give this answer. What is that answer? Okay, eto sagot ko. Because many students are quite discouraged to study because they would because there are some engineer telling, oh, you will only use 10% of your college, the knowledge you get in college, in in the actual life. You will only use 10% of it. But 10% is 10%. Unlike 0%. I better choose the 10% compared to 0%. Because I met an engineer like that. 10% lang naman ang gagamitin natin. Hindi naman tayo magki-Kirchhoff law sa construction. Diba? Sabi, no? Yan ang pilosopong sagot ng ibang mga profesional. That is a philosophy. You cannot use Kirchhoff law in construction in putting your lighting here, no, your outlet, your motors. Okay, use Kirchhoff law. Where is the application? I met an engineer like that. I'm sad. I feel sad for that engineer. He is a young engineer. Even old engineer, they would say, di naman natin pinag-aaralan yung pinag-aaralan sa school. Okay, this is my honest answer to the world. This is from the bottom of my heart. That's a fact that you cannot apply all the learnings in especially in engineering wherein we study almost 90% are theoretical. Kaya nga mababatingin sa atin ng mga technician eh. No? May mga technician, sasabihan tayo. The technician would say, engineers, they only know the theory. They only know the theory. We, technician, we know how to install. We know how to repair. Actual, we are better than engineers. Well, that's true. That's true. But remember, just like what I've said before in electrical principle, you cannot compare two different things at the same time. Who is more handsome? Me or Mopasa? You see Mopasa? May I saw our makinig ka, ano ha, baka may ganun thinking din si Cedric eh. Kung sakali lang naman ha, o kung sino man sa inyo ha. Kasi ang dami kong kilala mga pilosopong professional eh. No? Ito sagot ko sa inyo. Ito sagot ng academician. Hindi lang ako academician kasi trabaho rin ako sa Meralco sa construction. No? Ito sagot ko sa mga pilosopong yan. Ang hirap ng Englishin eh. No? You see, who is more handsome? Me or you look like Scar? You don't look like Simba. You see? Who is handsome? Me or Scar? Of course, you cannot compare two different things. At sabay galiway. Right? Technician is different than engineer. You cannot compare. That is the philosophy of the technician or electrician. Our engineer do not know how to operate this. Any electrician, look at engineer like that. Wala namang alam yung engineer namin eh. Hey, if you're thinking like that, this is my answer from the bottom of my heart. An engineer, are you watching everyone, are you watching NBA or PBA or a basketball game? Who is an engineer in a basketball? He is the coach. Who is the technician? Electrician, let's say in construction, they are the basketball player. They are the basketball player. Of course, do not ask who is a better player. Who is better? Steve Kerr or Stephen Curry? Although Steve Kerr is also a basketball player before. No? He's a teammate of Michael Jordan. Who is a better? You cannot compare because Steve Kerr is a coach. Who is better, Popovich or LeBron James? Cannot be compared because this is a coach. It's better to compare Popovich to Pat Riley or to Steve Kerr. There, because they are both coaches. Are you getting me, Leo? Are you getting me? Because Leo is also a technician, then he studied ETIAP, right? Tama ba?
Yes, sir.
Tama ba,
Yes, sir.
Leo? Because you are
Yes, sir.
an ETIAP. So, ibig
Yes,
sabihin,
sir.
technician ng work mo, right? Tama ba ako?
I am a power relay technician, sir, here in Saudi.
Technician ka. Of course, you want to upgrade as an engineer, right?
Yes, sir.
Okay. I'm wondering, no? Ba't mag-upgrade ka pa? Diba? Of course, kasi iba ang engineer. No? Okay. That is the philosophy of the technician. Hindi nyo naman ina-apply yan sa actual yung mga pinag-aaralan nyo. Okay. And even students. Sir, what is the application of Kirchhoff law? Then we solve this problem. Okay, it's a reality. Well, you can apply many things the theoretical in the licensure exam or in state board. That's one application. But no, sir, what we are asking in the actual life. You want actual life? This is my answer. There is application. Everything, sir? Yes. Everything you studied in college, there is application. I will prove to you. I will prove to those engineers saying, you will only study 10%. 10% lang magagamit mo. If a student, a first year student will hear that, what is the tendency for the student? Are you going to study hard? Oh, especially if you're the father. Oh, my father said I will only use 10%. I will not study hard. I'm wondering if the father will say that. But in fact, he's an engineer. Of course, he wants his son to become an engineer. Or shall we say, you are an uncle or just a neighbor. What are you studying? Electrical engineering. Sir, you will not use that. Only 10%. I am sad. This is my answer. Ang tagal ibig ng sagot no? I'll give you an example. Everything, sir? Yes. And this is my honest answer. You listen from the bottom of my heart. Pakinig kayong mabuti ha. Please listen. Para ito dun sa mga pilosopong mga tao na hindi daw nagagamit yung pinag-aaralan sa electrical engineering. Unang-una, nagagamit. First of all, in entry level in the company, there are companies requiring the license. Okay, let's stop with the license. Hanggang lisensya lang yan, hanggang board exam lang nagagamit. Ang tanong ko, sir, sa trabaho, yan kasi pilosopo ng ibang mga engineer sa technician. This is my answer with you. This is my answer. I remember, okay, we are on circuit. My professor loves to give us an infinite circuit. I'm wondering where is the application of this? What is the application of this circuit? I'm really wondering. We call this as a banig college. Ano yung banig? Para siyang banig or a mat. You see, this is an infinite circuit. Wow, this is one of the hardest circuit that we call. What is the resistance? There is a certain value. All the value is 100 ohms. Find Rxy. There is an infinite. There is a continuous circuit here. Infinite. This approaches infinity, infinity, upward, infinity, upward, infinity. The question, what is the resistance? My class said that, pambihira na, where is the application of this in our job as an electrical engineer? My professor said, okay, you go to Meralco, to the electric utility company. You go to power plant. Let the engineer solve that. That is my challenge to the engineer. That's what my professor said. He is a PEE, professional electrical engineer. He gave us this problem. Now, me, I really thinking, I research. Please listen carefully. This is very important. I research in our library. I even go to the library. We have I have friends. We were five in the tropa. No? We have five. I have four classmates. They are close to me. No? They are my friends. We even go to the library of the other schools to research the answer for this because it's not available in the books in our library. We did not find the answer. Then we try to solve because our professor gave a hint that it is mathematically an approach. But we spent around 2 to 3 days to solve this problem. Me, I slept around 2 to 3 hours only for the 3 days to solve and to find until I saw the solution in the book. Talagang chirahan natin. It takes a lot of effort. Napuyat kami, napuyat ako kakasolve nito. Puyat na puyat. Pagod. Pamasahe, pupunta ka pa. Transportation expenses because we have to go to the library of the other big schools. It needs a lot of effort. And one of my classmates, he did not sleep to solve this problem. One of my classmates, he did not sleep. I said, hey brother, you smell bad. Why? I did not take a bath. Why? Because I did not sleep. My mother told me that take a bath. If you did not sleep, mapapasma ka. Ano ba yung pasma sa English? It's very bad to your health. If you have no sleep, if you don't sleep, did not sleep last night, do not take a bath. It's dangerous. What I'm trying to say here is this. You work hard on it, right? I remember I work in construction industry. We are doing some estimate. Please listen ha, Sir Rick, Sir Garcia, Leo, kayo na lang po ang nandiyan dyan. I remember there is an estimate Estimation. Nag-estimate kami. We did not go home. We are on overtime. I almost did not sleep to make our estimation. Why? Because in college, we are practiced. We are accustomed to study hard and to sleep around 2 to 4 hours a day. We developed that when we were in college. We developed that because of the hard problems our professor is giving. My co-engineer said, "Why are you not yet sleeping?" No, I have to finish this so that we can win in the bidding. I have to finish this estimate. Our boss said that I have to estimate this portion. I will sleep at around 4 a.m. Then wake up at around 6 a.m. Di ako natulog halos. Buti na lang, nahasa kami nung college. Our professor was trained us. He gave us a lot of hard problem, no? From DC circuit to power system. And we did not, ano yung napansin? And we, no wondering, I really wonder, what is the application? Well, I developed the spirit of hard work. That those are just tools. Are you getting it, Leo? Sayang, umalis si Sir Garcia. Tatatlo na nga lang, umalis pa. Are you getting it, Cedric? Nakukuha mo ako? Hindi pa ako tapos. Iba yung na-develop. No? And there, no? Electrical engineering course is one of the hardest courses in the world. One of the hardest courses. I can assure you that. That belongs to top 10. Take a look at the survey in the YouTube. The top 10 hardest courses. Engineering is there. And in engineering, one of the top is electrical. Although you use specifically Norton's theorem, Thevenin's theorem in estimation, but you use the attitude or the experience you develop, the immersion you develop, the proximity you had with your professor. That's different. Okay? What you develop is the attitude. That's the most important. The values you learn when you were in college. Your professor is giving you a hard time, a hard problem. You did not wonder that, ganun pala yun. Dahil dito sa mga mahihirap na problem na to, ang na-develop pala sa akin yung pagsisikap. See? I'll show you another example. Did you watch Karate Kid? Papa! You watch Karate Kid? What is one of the instruction of the trainer? You clean the car. You see Karate Kid. Sir Garcia, have you watched Karate Kid? Leo, Karate Kid. But the instruction of his teacher is to wash the car. What is the relation of washing the car in martial arts? But there is relation. There is relation. The value of washing the car. There is soap. You see, you wash the car. Make it fast. And you lampaso. Ano yung lampaso sa taga-English? You mop the floor. And is He's great in moving like this. You wash the car. That is why if you punch, there's an enemy punching you, papas! Right? Sanay ka. Hindi yung paglilinis ng kotse ang gagawin pag nagkarate ka. Ang kukunin mo yung value na natutunan mo sa paglilinis. Nakukuha nyo? Are you getting me, Leo? Hindi naman mismo. Biro mo, lalaban ka ng martial arts paglilinis ng kotse. Hindi naman yung gagawin mo eh. Ang kukunin mo yung natutunan mo doon. What you will use is the value you learn in doing something. These are just tools. In psychology, we call this as stimulus or stimuli. In plural form, stimulus. Or is that correct? Stimuli, plural. I remember my psychology professor, Ma'am Lavarias. The one that will activate your mind. Those are just stimulus. Those are just tools. Well, there are engineers or technicians saying, oh, you will not use what you learned. I disagree. I disagree with them. Kaya yung ibang engineer, ay inis sa akin. Ikaw naman, yan si mga kaklase ko lang, inis sa akin yung iba dun. Yan naman si Reggie. Pagka puti kami lahat, siya verde. Siya pula. Pag pula kami, siya naman puti. Para bang di na kami laging iba yung style ni Reggie. Sabi sa akin ng mga kaklase ko, talaga. Mali naman talaga kayo eh. I will stand with my principle. What I believe from the bottom of my heart, that is the truth. Nothing but the truth. That is the use of what we study in Tagalog or in Taglish. Yung mga value na mo, pinagpuyatan mo to. Hindi mo alam na develop ka mag-work hard. Tools lang yan. Hindi yan eksakto gagawin mo. Pero yan ang naging daan para magsikap ka. Naging hakbang yan. Parang yung mga training, just like the training in the military. Some of those training are not used in actual. Some. But what's important is the value that you will get from that training. Is the value. Those things are just tools or instrument for you to understand the meaning of hard work. So for me, that is the function of this theoretical knowledge that we are studying. Okay, siguro hanggang dyan na lang. Mahaba yung sagot ko. Naintindihan ba ako, Leo? What can you say, Leo, on my answer? Sige, Leo, kasi maganda yung Sige nga, mag-comment ko nga. Maganda yung audio mo eh. Please comment kung naintindihan mo yung sinabi ko, Leo. Nakukuha mo ba yung Leo?
It's a very good thought, sir, for us. Actually, every situation you have to have a strong effort to achieve your goal. So, what I've learned based from my experience, like you are working abroad. Your only capital is your hard work. So that's my principle.
Hard
What
work,
I've
your
learned in the school.
attitude, right?
Yes, the best way is
Hard work.
your hard work and attitude. Yes.
Okay. That's more important than technical. I saw a
Yes.
lot of great engineers, but they are not good in their attitude. Sometimes others are stupid,
Yes.
are too boastful.
That is why in our life, sir, we have faith in God, attitude, hard work, and the learning will follow.
Yes,
After all.
technical is easy. That is secondary. There should be two content, technical and the values or the attitude. That's the most important. Number one is the attitude. You want to become successful in life? Okay, gain knowledge, gain technical, but do not forget a good attitude that will not fade. The technical knowledge will fade away. That will fade. But the attitude, the values that you will get will never fade. Okay, that's what I mean. Okay, Sir Garcia, anything you want to say? No more. Okay, sige, si Cedric, praso na lang. Cedric ba yan? Cedric, sige nga, naintindihan mo ba yung aking binanggit? Hindi para sa iyo yun, ha? General yun, ha? General. Okay, ano ang
Yes po, sir.
tayo magsara?
Guess,
Did you get may discussion?
like, yes, sir. It's a very magandang discussion. And for us
Were you enlightened?
to hear from that from you.
Were you enlightened about
Yes,
that?
of course, sir.
Enlightened ka ba? Have you
Of course,
heard this
sir.
answer
Yes.
before to your professor? Have you heard this answer before?
No, sir. Hindi ganito klaro.
Okay. Thank you, thank you. Okay, we will
Thank you po.
thank you very much, ha. Thank you. Pero kayo nasa Zoom class, stay put lang kayo dyan. Kahit tatlo lang kayo dyan. Anyway, I have to show this to our friends. No? I thought I was only in the Zoom class. But we're still our non-Filipino friends who are watching. Okay, so this is our first study of electrical engineering professional subjects. So I will discuss all this topic, but I am just only on topic number 2. Okay, this is only circuit. We have a lot of discussion on DC. Of course, in topic we will discuss. We have a time frame, more or less 1 year, to discuss all the topic, the 16 topics here. So I'm inviting everyone to attend for free. This is a free lecture online. This is MWF 9 to 12 p.m. This is Philippine time. Okay, although we have a different time zones. The Zoom ID will be posted in our Facebook account, the Marina's Powerhouse Facebook account. And I'm inviting everyone to the Master Electrician Fundamental course. These are for the technician. Anyway, I will just discuss this with our Filipino friends. This is our Facebook account, Marina's Powerhouse Facebook account. And this is my YouTube channel. Okay, study electrical engineering the Filipino way. We have to show to the world that there is a Filipino giving lecture electrical engineering. So we are serious about this. We are just on we just started last June when COVID arrived. You see, so we want to share the quality of our review and training center. Okay, we want to help. That is our number one intention. We want to help students all over the globe. Wherever you are, whatever your success is. So we will help you by just giving this lecture on YouTube. And please share. Please subscribe, like, share, and put a comment. No? Mag-comment kayo mga kawerpa. Sana makita natin yung inyong mga positive comments sa ating video. I-upload po namin ito. Okay? So just subscribe to my YouTube channel, the Reggie Marina YouTube channel. Okay, with this, I should say thank you very much, all our friends. God bless you all and stay safe.